This is part two. So these two, as I was just saying, these two are exactly the same molecule. All we've done is we flipped them over. All right, we've rotated them. I hope that makes sense. If you rotate this, like in this, like kind of rotate it around, one becomes the other. So it doesn't really matter where you put the double bonds. Okay, there you go. I hope that was kind of interesting to you. But there you go. So it doesn't really matter where you put the double bond. All right. So there's these two are the same, and the next one. Let's draw the next one. Whoops, let me just, gosh, I don't know why this thing keeps making funny noises. It's not me. Right, so the next one is carbon 4. 1, 2, 3, 4. Now I'm going to put the double bond there. Okay. Here we go. My internet's bad, I can tell, because my drawing is lagging now. My internet's been awful these holidays, actually. It's been awful. I don't know about you guys. Okay, there you go. I can put the double bond there, or I can put the double bonds between the middle two. Okay, there. I hope you're aware of this. But we can put the double bond there, or you can put the double bond there. Okay. Isn't chemistry easy, though? Or compared to physics, it's much easier. All right. So there you go. Now, but these two are not the same. These two, not the same. How am I going to show that? They're not the same. Not the same. Yeah, my pen is dying here. That means the internet's dying. All right, so the pen is they're not the same. Now, the reason these two are the same down here for the propane is because the double bond is at the end. It's at the end and it's the end. All right, but here the double bond is at the start, and then the double bond is in the middle. Okay, now let's see how good you guys are. 1, 2, 3, 4. If I drew this one, is this a new one? So answer in the, what do we call this? In the in-call messages. Have I drawn this one before, or is this a new one? Okay, it's taken me a long time to draw. It's not me because I'm a slow drawer. It's because my internet is dying here. Have I drawn this one before, anyone? Maybe you can't. Maybe, are you even still there? My internet sucks today. It really does. It's been like this for ages. Are we good? Is anyone there? Thumbs up if you're there. Oh, thank God, Arona, you're still there. Does anyone, have I drawn this one? I'm going to call this one number 1. This one number 2, and this one number 3. All right. Number 1 and number 2 are not the same. What's number 3? Is it a new one, or have I drawn it before? Is it the same as number 1 or number 2? What do you think? Anyone at all? You can draw this in the comments. It's not the same as 2, darling. No. Because number 2, the double bond is in the middle. Well done, Paletta. Number 1 and number 3 are the same. All we've done here is that the double bonds at the end there, the double bonds at the end there. So 1 and 3 are the same, but 2 is different. Well done, Paletta. All right, Quetzal keeps coming and going. Quetzal, is your internet as bad as mine? It sounds it, eh? God, I don't know. You know what? I had the guy, I shouldn't be talking about this on the video, should I? But I had the guy from BTC. He came and he just said, yeah, there's nothing we can do. No, it sucks. I'm in a bad place, though. I live in Habaroni North, and that's not a good place for internet. It just isn't. All right. Anyway, let me stop going on. All right. So there you go. So does anyone know what we're going to call these 3 guys here? I'm going to get rid of the 3. Get rid of the 2, because I just don't want them anymore. Yeah, gosh, my pen's awful. So, ladies and gentlemen, what do we call these 3 things on the right? These, they have the same molecular formula, but they have different structures. These are called isomers. Okay, they're isomers. Isomers of butane. Right, now let's say, what are these guys called? All right. Well, the first one, let me get a different color. Nice different color. First one's going to be eth, because there's 2 carbons. Next one's going to be prop. And this one's going to be pro as well, isn't it? Because they're the same. This one's going to be but. This one's going to be bute. And this one's going to be bute, even though 1 and 3 are the same. Okay, now they're alkenes. So that means we've got to give them a different suffix now, ene. Why are they alkenes? Because they've got a double bond. Propene. Propene. Now this top one is called butene. Believe it or not, the middle one is called butene. And the bottom one is called butene. But now we have to, a weird thing, we have to put a number in it to tell me where the double bond is. Okay, so the double bond is, where is the double bond? Well, we count carbon atoms. 1, 2, 3, 4. 1, 2, 3, 4. And in number 1 here, where does the double bond start? It starts at number 1 and it goes to number 2. So you pick the lowest number, number 1. So this is called but1ene. The middle one, where does the carbon atom, where does the double bond start? It starts at number 2 and it goes to number 3. You pick the smallest number, 2. So this one is called but2ene. Now, using this logic, you might think the bottom one is called but3ene. But what happens is, if we count from the other end, if the functional group is at the other end, we count from the other end. So now we count from this end. 1, 2, 3, 4. So again, here the double bond goes between 1 and 2. Pick the smallest number. So this is but1ene. And that tells us it's the same as that. All I've done is I've rotated it kind of like that. Okay, does that make sense? I hope we're all good. Thumbs up for good, thumbs down for bad. Are we good? All right, good stuff. Right, now alkenes, as we've said before, because they contain a double bond, these are known as unsaturated hydrocarbons. Okay, and they're unsaturated. Now, what's the formula for all of these? This one is C2H4. Propane is C3H6. All of these are C4H8. So you can probably see what the general formula is here. So the general formula is CnH2n. Okay, and again, you got to remember that, CnH2n. All right, so that's the general formula of alkenes, CnH2n. All right, so if I asked you, well, what's the formula of an alkene with 32 carbons? Okay, what's the formula with 32 carbons? Well, it's very simply C32H, 2 times 32 is 64, and that's it. That's how we do that. Okay, so that's alkenes, all right? And now we've got to look at the chemical properties of alkenes. So these are alkenes, okay, and these are chemical properties. Now, even though you don't do this, number one, they will burn. You shouldn't burn them, but they will burn. So number one, alkenes will combust. No one burns them because they're too useful, but they will combust. And let's pick one at random. All right, let's pick, I don't know, C4H8. I'm going to burn it in oxygen. And if I combust the carbon, I'm going to get carbon dioxide. If I combust the hydrogen, I'm going to get water. So you get the same things. So all hydrocarbons always give these two things, eh? All right, because they must. That's all they can give. So let's balance it now. Well, there's 4 carbons here, and there's 4 carbons there. There's 8 hydrogens here, and that means there's 4 there. I count these. 2 times 2 times 4 is 8 oxygens there, plus 4 oxygens. This together makes 12 oxygens. That means this number is 6. And there you go, same as before. Now, they will combust, but we don't combust them, so I'm not going to really talk about combustion anymore. Number 2, they take part in what we call addition type reactions. These are addition reactions. All right. Now, what's an addition reaction? Well, let me move this up a tiny bit. An addition reaction is very, very, very simple. Very, very simple. If you have two things, A plus B, they come together to give one product. So that's all an addition reaction is. Two reactants gives one product. That's all it is, okay? Now, the common one here for alkenes is the reaction with bromine. Okay, so I'm going to draw this nicely. First of all, I'm going to do a reaction. C2H4 plus bromine, Br2, is going to give me C2H4 Br2. They've just added together. And this is a typical addition reaction. There's a typical addition. Now, to explain this, it's nice to draw them the nice formula. So let's draw this. This is my alkene. I'm going to draw it in a funny way here. There's my ethane. Okay, there's ethane. And I'm going to react it with bromine. There's a Br, and there's a Br. Okay, and now what's going to happen is they're going to come together, and we're going to get this CH, H, CH, CH. Now, bromine is one of it's going to go on one side of where the double bond was, and the other one's going to go on the other side of where the double bond was. So can you see that this is an addition reaction? Because two things have formed one thing. Okay, so far so good. Now, what's this guy called? I don't think we really have to know what it's called, but I'm going to tell you anyway. All right, now it's no longer a double bond. It doesn't have a double bond thing anymore. It's all single bonds. So it's no longer an alkene. This was an alkene. All right, this one looks more like an alkane. So we name it after the alkane. So it's called ethane. This one was called ethene. This one's called ethane. All right. Now, what have we got on the ethane? Well, we've got two bromos. So we call this, believe it or not, this colour, we call it dibromo. Because it's got two bromines on. 1, 2. And one of them is on number 1, and one of them is on number 2. So we call this thing 1,2 dibromoethane. Okay. Now, I think we're all getting a bit tired now because we've been on for a long time. But are we all good? Can I carry on for another 5 minutes, or are you done now? Anyone? Are we good? We'll carry on for a little bit longer. Okay. Because I don't want to keep you too long because I know I've been going on. Now, all right, this is an interesting reaction, and I'll show you why. Okay, so here we have a beaker. Okay. And in the beaker, there's some water. I've dissolved some bromine. I've got bromine, and I've dissolved it in water. Bromine dissolved in water. Okay. Now, bromine dissolved in water is given a special name. It's called bromine water. All right. Now, and we often give it the symbol Br2 aqueous. Okay. Now, bromine water, as you may or may not know, it's got the color of bromine. So bromine water is actually brown, orange brown. Okay, so this is bromine water, and it's an orange, it's like a dark orange color, brown. Now, into this bromine water, I'm going to pipe in, I'm going to bubble in some ethane. Okay, so there we go, and I'm going to bubble ethane in. Sorry, ethene in. Ethene goes in there, and there's bubbles. Now, what's going to happen, believe it or not, okay, if I bubble this stuff in, the bromine goes out of the water and it bonds to the ethene, and the water, stop making that funny noise, the water goes colorless. Okay, so bromine water goes colorless. Now, the bromine water, therefore, bromine water can be used to test for a double bond. Because if I put ethane in here, nothing will happen. But if I put ethene in, it will go from brown to colorless. So bromine water is a test for a double bond. In other words, we can use bromine water as a test for alkenes. Okay, so the last thing we'll do today is this. How can you tell an alkene from an alkane? Okay, so here we are, alkanes. And these are alkenes. Okay, so the first thing I'm going to do, C3H8. C3H6. Now you can see there that the one on the left is C3H8, so you should be able to see that the one on the left is CnH2n plus 2. And if it fits this formula, it must be an alkane. This one is CnH2n. Okay, if it fits this one, it must be an alkene. So you should be able to tell alkenes and alkenes apart by their molecular formula. You should be able to tell them apart because of their molecular formula. The next thing, how else can we tell them apart? Well, let's draw them. 1, 2, 3, and this is propane, isn't it? Oh God, my internet is dying. It's so slow. There's so much lag here. All right, and there's propane, and now I'm going to do propene. All right, there's propane. Now, as you can all see, hopefully, you can see one's got a double bond. So you've got to tell them apart by their what should we call this? Their structural formula. So you can tell them apart by their molecular formula. You can tell them apart by their structural formula. How else can we tell them apart? Well, obviously, we can tell them apart by their names. Propane, propene. Okay, so we can tell them apart now by their suffixes. Propane is an alkane, propene is an alkene. And the last way we can tell them apart is how they react with bromine water. Okay, alkanes don't change the color. There's no reaction. In other words, it stays orange, brown. And this one goes from brown, orange brown, I should say, brown to colorless. Okay, so they're the ways you can tell an alkane from an alkene. The name, I've got to write the name there, haven't I? Write the name. So are we all good, guys? Are we all good? Yeah? So that's all we're going to do for today. What day is it today? Friday. Now, annoyingly, I don't know what's happening on Monday because, who knows?